Today we're going to look at our trig ratios to solve right triangles. So far we've used Pythagorean theorem, which is helpful when we have 2 out of our 3 sides. We can do a squared plus b squared equals c squared. We also looked at our special right triangles, which were the 30, 60, 90 rules, and the 45, 45, 90 rules. So the last type of method that we can use to solve right triangles is going to be our three trig ratios. So these are helpful when you can't use Pythagorean theorem, and if your triangle is something other than 30, 60, 90 or 45, 45, 90, because not all triangles are going to have those angle measures. So first thing that we're going to do is just a little bit of intro vocab. So if you're looking at this triangle, I'm going to go ahead and just label this right angle here. So you can go ahead and just draw that in. And then hypotenuse, we know, is always across from the right angle. So this side would be your hypotenuse. And then the legs of the triangle are your other 2 sides. So we would have, this would be one of our legs of our triangle. This would be the other. Okay, we're also going to refer to opposite sides and adjacent sides. Opposite means across from. Adjacent means next to, which we're going to look more specifically at how those will look in the next example. Okay, so if I go down to number 1, it says name the side of the triangle opposite angle X. So if we're standing at angle X, the side opposite that is going to be across, which is YZ. I'm just going to put that line over it to show that this is a segment that ends. So YZ would be the opposite side. If I'm at, for number 2, angle Y, name the side opposite angle Y. That's going to be XZ. And then the side opposite Z is going to be XY. So again, opposite is going to mean across from. Okay, if I go down to number 4, it says label the appropriate sides as adjacent, opposite, and hypotenuse with respect to the marked acute angle. So we're going to always refer for this problem to angle K. So if I do the adjacent side, okay, that's going to be the side next to K that is not the hypotenuse. So JK would be my hypotenuse because it's across from the 90. So the side adjacent is going to be KL. Okay, opposite is going to be the side across from angle K. That's going to be JL. Okay, and then the hypotenuse is going to be that long side across from the right angle. That's JK. Okay, so one thing you want to make sure with the adjacent side, that does not include the hypotenuse. You would want the side next to that angle that is not the hypotenuse. For number 5, again, we're going to use the marked angle R. So we would have the adjacent side. That's going to be QR. The opposite side. So if I'm standing at R, opposite side is QP. And then the hypotenuse is going to be PR. Again, hypotenuse is going to be that side across from the 90. That's going to be the longest side. Okay, if I go ahead and flip. So when I get into trig ratios, okay, there's going to be 3 trig ratios that we're going to use in this class. So first one is going to be sine. And what's going to happen when we write these trig ratios is we're going to write them as a ratio, which means a fraction. So sine is going to be the opposite side. That's going to be in my numerator over the hypotenuse. It has to be in that order. So the opposite side will always be in the numerator, and then the hypotenuse will be the denominator. So it will look like opposite over hypotenuse. Okay, cosine is going to be adjacent And then hypotenuse will be the denominator. So that's going to be adjacent over hypotenuse. Okay, tangent is going to be the opposite side over the adjacent side. So it would be opposite over adjacent. Okay, so when we write these, again, order matters. It has to be opposite side of numerator, hypotenuse in the denominator. Okay, there are also reciprocal trig functions, which we will not use in this class. But basically what they are these three just flipped, which is what the reciprocal means. So this would be hypotenuse over adjacent. Again, we're going to focus on the three primary trig ratios. Okay, to help you kind of remember these relationships, so opposite over hypotenuse, there is a little rhyme that you can use, and it's called SOHCAHTOA. So what this means is if this is the sine ratio, you're going to do opposite over hypotenuse. If this is the cosine ratio, you're going to do adjacent over hypotenuse. And if you use the tangent ratio, you're going to be opposite over adjacent. So that's kind of a nice thing that I will refer to as well. That's going to help you remember those ratios. Okay, so if I'm looking at this first example, it says write the sine, cosine, and tangent ratios for angle x. So sine, I'll start with. Again, sine is going to be opposite over hypotenuse. And then we're standing at angle x. So O is going to refer to the opposite side. So that would be the 3. Over my hypotenuse for this example is going to be 5. And then if I have cosine, cosine is going to be adjacent over hypotenuse. So again, I'm standing at angle x. Adjacent is going to be 4. Hypotenuse is going to be 5. And then tangent so if I'm standing at angle x, tangent is going to be opposite over adjacent, which would be 4. So again, this little rhyme, SOHCAHTOA, is going to help you remember that order, okay? And again, order matters. So for example, for sine, opposite should be your numerator. Okay, and then for y, if I'm standing at y, I'm going to do sine. Sine is opposite, which would be the 4, over the hypotenuse, which is 5. Cosine is going to be adjacent over hypotenuse. And then tangent is going to be the opposite side, which is 4, over the adjacent side, which is 3. Okay, so what we're going to take a look at next is we're going to give you a trig function and a angle. So I'm just going to write the SOHCAHTOA here because that's, again, going to help us know what order we're going to write things in. So if we have the sine of A, we're going to stand at A. A is opposite over hypotenuse, so opposite side is 3. And then the hypotenuse is square root 13. Okay, again, we do not want a radical in the denominator, so I'm going to go ahead and rationalize. So I'm going to multiply top, bottom by square root 13. So that's going to give me 3 square root 13 over 13. And then it's asking us to write that also as a decimal. So we're just going to type that into our calculator. So we're going to do 3 square root 13 divided by 13. And we're going to round to 4 decimal places. So that's going to be 0.8321. And that's going to be the sign of A. Okay, and then we have tangent of C. So we're going to stand at angle C. So whatever angle we give you, that's your angle that you're going to be pulling your opposite side and adjacent side from. So tangent, again, is going to be opposite over adjacent. So opposite side is 2. The adjacent side is going to be 3. And then if I type in 2/3 in my calculator, that's approximately 0.667. And then cosine of A, so if I'm standing at A, cosine is adjacent over hypotenuse. So adjacent is going to be 2. And then hypotenuse is going to be that square root 13. And again, I don't want a radical in the denominator. So I'm going to rationalize. I'm going to multiply top and bottom by that radical. So that would give me 2 square root 13 over 13. And again, I'm going to type that all in my calculator. So I have 2 square root 13 divided by 13. And that's 0.5547. I'm going to have you guys pause and go ahead and do the bottom 4. Okay, if you want to take a look. So tangent of A would be the opposite side and adjacent side. That's 3/2, which is 1.5 as a decimal. Cosine of C is going to be adjacent over hypotenuse. And then again, I can't have a square root in the denominator. So I'm going to rationalize, multiply top and bottom. And then for sine of C, that's going to be the opposite over hypotenuse. And again, I can't have a square root in the denominator. Okay, next thing that we can do is go ahead and evaluate angles. So what you want to make sure here is if you have your calculator, if you go to mode, you want to make sure it's the 3rd row down that your degree option is highlighted. So you want to make sure that you're on degree mode. So this should be highlighted. Radian mode will give you really weird answers. So once you're on degree mode, if you hit second quit, you can go ahead and type in sine, which is going to be this button here. So your sine, cosine, and tan are going to be these 3 functions here. So sine of 32. Okay, and we're going to round to 4 decimal places. So that's going to be 0.5299. And then we have cosine of 54. That's going to be 0.5878. Sine of 30 is going to be 0.5. Tan 45 is going to be 1. Cosine of 69 is going to be 0.3584. And tan 22 is going to be 0.4040. Okay, you always want to make sure that you're in degree mode for those.